Good morning, friends. I am Prashant Mahajan. So today we are going to see the methods of corrosion control. So there are five to six methods that can be used for the corrosion control. So first is proper designing and material selection. Let us see the first method. So material selection. That means, as we know, galvanic series. So first thing you are going to do, use corrosion resistant metal, that is cathodic end metal. Second, use pure metal. If you are using an impure metal, then it is going to form galvanic cell, and if it is coming in contact with the electrolyte, then there will be galvanic cell corrosion. Then third point is use alloy. So alloy is having more strength and it is corrosion resistant. Then use single metal, that should be preferred because single metal will not form galvanic cell. Then fifth one is use two dissimilar metals. Sorry, use of the two dissimilar metals should be avoided. If possible, use closer metal in the galvanic series. As I said, if the two metals, if you are using, then the distance between the two metals should be less. If the distance is more between the two metals, then there will be faster corrosion. And last, if you are using two metals, then insulate that two metals. That means it will it will be in it will not be in the electrical contact. So that is material selection. Next is proper designing. So you can see the design. Do not take such type of designs. Take such design so that there will not be accommodation of water, dirt, dust, or conducting medium. So first, avoid contact of two dissimilar metals in corroding solution. Then anodic metal should have larger surface area than cathodic area, because see, if the cathode is having more area, then it will demand more electrons. That means the electrons will be provided by anode. So if the area of cathode is more, then anode will oxidize faster. And next is proper fabrication should be done. So this is the example of proper fabrication. If you want to do the fabrication, make such type of design so there will not be accommodation of water, dirt, or dust. So that will it will not be acting as a corroding medium. Then next is no crevices between adjacent parts. So there should not be crevices, so that there will not be crevice corrosion. Next is sharp bends and corners should be avoided. So this is the example of that. Then surface should be kept clean and free from dirt, dust, and soot. So it should be clean. Then welded joints are preferred instead of nuts and bolts and rivets. Because see, if you are using nuts, bolts, and rivets, then it is made from different metals, and base metal is different metal. So it will be formation of galvanic cell, and if it is in contact with the electrolyte, there will be corrosion. Next is no accommodation of water on metal surface. So there should not be any accommodation of water, so it will provide the conducting medium for corrosion. So this is material selection and proper designing. Next is modification in environment. So there are four methods. First is de-aeration, means removal of oxygen. So as we know that oxygen evolution mechanism is taking place due to presence of dissolved oxygen in the water. So if we remove that oxygen from the water, then the corrosion will not take place, or oxygen absorption mechanism will not take place. So see, deactivation is done by increasing temperature. So you are going to increase the temperature, that oxygen will get removed. And second is deactivation. That means you are going to deactivate that oxygen by using chemicals like hydrazine. So hydrazine will react with the oxygen and it will give you nitrogen plus water. Or you are going to use sodium sulfide. Then reducing moisture. So oxygen absorption mechanism is taking place in the presence of moisture. So you are going to use silica gel so that it will absorb the moisture present in the environment. And last, that hydrogen evolution mechanism is taking place due to presence of acidic environment. So neutralize that acidic environment by using chemicals like lime, NaOH and ammonia. So this is called as modification of environment. So if you know the cause, then you are going to use the preventive measures. Next is corrosion inhibitors. So what is inhibitors? Inhibitors are the substances that are used to prevent the corrosion or that are going to be added in the corrosion medium. So that will reduce the rate of corrosion. So first is anodic inhibitor. So for that you must know hydrogen evolution mechanism and oxygen absorption mechanism. So in the both cases the reaction is taking place at anode and that Fe is going to oxidize to Fe plus 2. So you are going to add oxygen or oxidizing agents like chromate, phosphate and nitrates. So that will combine with the iron metal and it will form ferrous hydroxide. So that ferrous hydroxide will be making that electrode passive. That means there will be no reaction at anode. So that is the role of anodic inhibitor. That means anode become passive. And second is cathodic inhibitor. So that means we have to make the cathode passive or we have to make the electrolyte neutral. So first in the case of H plus evolution, so we know that that is taking place due to acidic environment. So organic inhibitors like amines, mercaptans, urea, thiourea reduce the diffusion of H plus. So due to addition of amines, that H plus diffusion is reduced. Then second, we are going to add mercury, arsenic and antimony that will deposit on cathode. That means there will be no demand of the electron by the cathode. B part is that is oxygen absorption mechanism. So first thing it is taking place in the presence of alkaline medium. So we are going to form hydroxides of that alkaline medium like we are going to add magnesium, zinc and nickel so that it will react with the hydroxide and forms insoluble hydroxide which are deposited on the cathode forming barrier. So in that case, in that way, that cathode becomes passive. And second thing, it is happening due to presence of oxygen. Then we are going to remove that oxygen by adding sodium sulfide or deaeration. So that is called as use of inhibitor. Next is the cathodic protection. So cathodic protection, the word itself indicates that the metal to be protected is supposed to behave as cathode. That is called as cathodic protection. So there are two types of methods for cathodic protection. That is first is sacrificial anodic protection or that is called as galvanic protection. That means the metal which is placed above the base metal in the galvanic series is connected to the base metal. In that case, the more active metal will be acting as anode and the base metal is acting as cathode. So in that way, the metal pipeline or the metal structure to be protected will be protected as it is behaving as cathode. So metals like magnesium, zinc and aluminum is connected to the base metal. So you can see the diagram. First, this is pipeline to be protected. Then insulated copper wire is attached. Then the magnesium, aluminum and their alloy is kept in the backfill and that backfill is used for the increasing the electrical contact. So this is the diagram for sacrificial anodic protection or we can say galvanic protection. So more active metal will be acting as anode. In that way, that pipeline will be acting as cathode and this metal is get corroded. So it is sacrificing itself. So these are the advantages of the sacrificial anodic protection. First, no external power is required. Second, easy to install. Third, anodes can be readily added. Fourth, maintenance required is minimum. Then limitations are limited driving potential, limited current output. It can be ineffective in high resistivity environment. Poorly, sorry, poorly coated structure may require many anodes. That are the limitations and where we can use. First, buried steel pipelines, ship hulls, hot water tanks, and buried cables. So see the pipelines which are buried under the soil surface below 20 or 30 feet, that can be protected by this method. So what you have to do, just connect that pipeline with one wire and make the hole above 5 to 6 feet and keep their backfill, so that backfill metal can be replaced when it is consumed totally. So in that way we can protect that buried pipeline from the corrosion. So this is first method. Then second is impressed current method. So in this case we are going to supply the direct current in the direction of, sorry, in the opposite direction to nullify the corrosion current that converts corroding metal from anode to cathode. So that means we are going to supply the negative charge to the pipeline and positive charge to the backfill. So backfill is containing graphite and stainless steel. So due to change in the terminals, that negative terminal attached material will be acting as cathode and that positive terminal metal will be acting as anode. Remember, it will be used where the resistivity is high. So that is called as impress current method. That means the current is applied in the opposite direction to nullify the corrosion current. In that way, the anode is converted into cathode. That is called as second method of the cathodic protection. The advantages: first, large structure can be protected for long-term operations. Second, can be designed for wide range of current and voltage. Third, it can be applied in high resistivity environment. Fourth, effective in protecting uncoated and poorly coated environment. Limitations: it can cause cathodic interference problem. Second, require periodic maintenance. Third, external power is required, resulting in monthly power cost. Overprotection can cause coating damage, and where it can be used: open box, water box coolers, water tanks, buried water tanks, and gas pipelines, and condensers. So it can be used in the four of them, that is open water box coolers, water tanks, buried water tanks and gas pipelines, and condenser. So these are the two methods of cathodic protection. In that, first, sacrificial anode, we have connected base metal to with more active metal, and in the second case, we have connected negative terminal to the base metal. In that way, it is protected from corrosion. The next is anodic protection. So the word itself indicates that the metal to be protected by from the corrosion is forced to behave as anode. That means we are going to make that base metal passive. So it can be shown by the metals. Those are showing active passive behavior like aluminum, chromium, nickel, titanium. So you can see the diagram. So this is the diagram which is an auxiliary electrode, reference electrode, and the negative terminal is connected to anode, positive terminal is connected to cathode. So what happens, that electrolyte is having chromate, phosphate, borate. So the metal or the aluminum present in the tank will be coming or will be dissolving as Al3 plus, and that will be reacting with the oxygen present in the electrolyte, and it will form oxide, and that oxide will be depositing on the base metal or tank metal. So that oxide will prevent that anodic metal from further corrosion. So that is anodic protection. That means we are going to oxidize that metal, then that oxidate state will react with the oxygen present in the electrolyte, and that will deposit again on the anode, and that anode becomes passive, and that will act barrier for the further corrosion. So for that we are going to maintain electrode potential and voltage. So you can see in the diagram. So we have to make we have to adjust that electrode potential in between 0 to 0.5. That will be corrosion rate will be 10. If the electrode potential decreases below the 0, then the corrosion rate will be 1 lakh times, and if it increases above 0.5, then the corrosion rate will be again above 1 lakh times. So that is working and principle of the anodic protection. So there are some limitations and advantages of this method. So first is, method can be applied to severely corroding medium like concentrated acid. It requires low current density, hence its operation cost is low. Limitations are there, applicable to only those metals which exhibit passivity. During anodic protection, corrosion takes place in small amount but not zero. So it is going to take place, as you can see, that is 10. Second thing, it will be applicable to only passive, active passive behavior showing metals. And advantages, it can be used in corroding medium and its operation cost is low and current density is low. And applications, you can see where the corrosion is faster, in this place anodic protection will be used. So chemical reactors, tanks, pipe carrying corrosive liquids, pipe carrying concentrated acid. So that is anodic protection. Then next is difference between cathodic and anodic protection. So first, cathodic protection is applicable to all metals. Anodic protection, as I said, it is applicable to the metals those are showing active passive behavior. Second, use for the metal protection in less electrical conductance. Here the electrical conductance will be high. Then third point, installation cost is low. Here installation cost is higher. Fourth point, in case of cathodic protection, operating cost is higher. In case of anodic protection, operating cost is lower. Next, cathodic protection, if the system goes out of control, slow corrosion is observed. If the anodic protection, if the system goes out of control, there will be fast corrosion. And last, feasibility cannot be checked at laboratory scale. In the case of anodic protection, we can check the feasibility at lab scale. So that are the some points which can differ the anodic and cathodic protection. Thank you.